Welcome to this Sahara 4 exercise. In this exercise, we will do our first bubble map based on the petrophysical information that we have imported from the previous exercise. For that, we are going to open Sahara and open the previous exercise where we imported the information. Then with the project open, we are going to open the map window over here. Here, as we are only going to work with the map window, we can expand it. There is a tool here, auto configuration, in the view menu, where we can expand it completely, or by doing the shortcut Control A. Um, we are going to expand completely the map so it can cover the entirety of our screen. The next step will be to open the window configuration tab. For this we have two options. We can either right click and configuration, it's going to open the tab, or we can click on this button over here to open the tab. Once the tab of the window map is open, we are going to select bubbles, and here our next step is going to check this. Either we can do it with this or with this button or with this checkbox to select the bubbles and show them. And then we need to select which variable are we going to graph on these bubbles. So we are going to go to the variable selector. We can either right click here and click on variables, or we can click on this icon here to open the variable selection. The variable selection windows work on a tree. It's like a tree structure where we have different branches that allow us to show different information. In this case, we are going to focus on petrophysical data, but here we have object data, multi-productions, or information associated with flow elements. In this case, as I said, we are going to go with petrophysical data. Then we have the different variables that we have imported from the previous exercise belonging to the petrophysical data variable group. We have net thickness, gross thickness, porosity, the top of the layers and the base, and the pore volume that has been calculated from the previous data that we have imported, as we saw in the variable exercise, where some variables are calculated from other variables. In this case, we are going to select net thickness. In net thickness, we are going to have the option of visualizing the information on an object level, or if we have information loaded, petrophysical data loaded at the object level, or for each layer. In this case, we are going to select layer so we can see the net thickness associated with each layer for each well. We click OK. Okay, and now the bubbles are plotted. Now we can see that we are plotting the net thickness of this layer in each well, but the bubbles are too big for us to see anything meaningful, so we need to reduce their size. The first thing we have to consider here is that we have two different menus. One menu is associated to the bubbles themselves. It's a general bubble menu in the map. This is going to allow us to change which variables are selected. Is going to allow us to decide which format of the bubbles are being plotted. This allows us to switch between different variables. And here, this is going to allow us to decide what is the relationship between the radius or the area, or which condition is going to be considered when plotting respect to the variable that we want to show. In this case, for example, this option linear makes the bubble radius proportional to the variable that we are plotting. In this case, net thickness. This one is going to make the area of the bubble proportional to the net thickness. For example, if we change, we see that they were reduced in size a little bit. Here with logarithmic, we are going to make the radius of the bubble proportional to the logarithm of the value that we are plotting, in this case net thickness. This is especially useful for those cases where you have a lot of dispersion, for example with permeability, where you may have very different values and you need to see the differences. With uniform, all of them are going to be the same size, so we don't have any difference in the radius, but this may be useful if we are not interested in in the radius, and we want to use, for example, different colors to show different things, which is not the case in this opportunity. So we are going to keep here with linear, and we are going to reduce their size. There are two ways, sorry, to reduce the size of the bubbles. One is reducing the factor here. This is going to multiply the radius of the bubbles by a factor and going to reduce their size. Now we have something more relevant. We can see that we have bigger thickness on this side, while on the west we have a reduction in thickness that is quite clear. But other option will be to go with 100% without any factor, and go into the other menu, the menu that is associated with the variable, and here we go from the scale that is in automatic. We are going to reduce it to first 5 to 1 and then 2 to 1. In this case, we are also reducing the size of all the bubbles, modifying the scale. That is the relationship between, in this case, the radius of the bubble and the thickness of the reservoir. In the case that we have selected here, for example, area, the scale is going to modify the relationship between the area of the bubble and the net thickness of the layer in the different wells. We can also graph the values of the of the bubbles. We can see exactly how much net thickness we have in each well. For this, we have to go here, select values, and we can see here, for example, that in the well D40, in this layer we have 7.68 net feet of net thickness. We can also change where this information is going to be shown. For this, we need to go to here, values position right, for example, and this now the value is going to be represented always at the right of the bubble, or the center, or the top, left, right, down, up. It's going to be at the top of the bubble. So we can modify that as well. We can change the color of the bubbles by clicking here. We can switch them to, for example, yellow, and we are going to have a more clear view of the name of the well and the variable that we are representing, the net thickness. Switch between different layers. For example, we can see here that we have net thickness only loaded for these wells here. We can change quickly with using these arrows on the top. With this selector, we can move between the different layers and see how the net thickness changes along the reservoir. Here, if the scale is set to is not set to automatic, we are going to see comparable values between the radius of the bubbles. So with this, we can see how the values change in each layer. We can select more than one layer by holding the Control or the Shift key and clicking on them. In the case of the Control key, we can select the layer that we want to add up. So we can add any layer that we want by pressing Control. And if we use Shift, we are going to add all the layers between the first one that is selected and the last one. So all these layers in the middle are going to be selected. As you can see, when we start clicking and adding more layers, the bubbles start to get bigger and bigger. This is because of the aggregation function defined in the variable. As we discussed previously in the exercise 7, the exercise of the variable window, each variable is going to have a different aggregation function. In this case, let's check for net thickness, petrophysical data. We can see that the aggregation function is going to be the sum, which means that as we add more and more layers, the radius or the area, how the size is defined for the bubble, is going to get bigger and bigger because we are adding all the net thickness of these different layers. But this is not always the case. For example, it wouldn't make much sense to sum, for example, porosity. So porosity in this case is going to be a weighted arithmetic mean of the net thickness, which means that instead of plotting net thickness, we plot the porosity bubble, the total value of porosity that we are going to represent at the end is going to depend on the porosity of each layer, but it's going to be weighted by the net thickness, which means that the layer that has the most net thickness is going to be more representative of the total porosity of the bubble that we are plotting. Something to consider as well that is quite important is that we have more than one format. This is the basic one, simple, that is just going to plot the variable, and is going to show us different radius or area of the bubble depending on the variable. But for example, we could use this one, the format per layer. This one is quite interesting because it's going to show us, as you can see, I'm going to reduce the factor a little bit so we have a more clear view. It's going to show us this pixagraph of the bubble where the total radius in this case, and we can change it using this. It could be area, could be logarithmic. In this case, we are going to keep it to the radius. The total radius of the bubble is going to be proportional to the total net thickness of all these layers combined, but we can also see how much each layer is adding up to that total. So that allows us to have very interesting conclusions quite quickly. For example, we know that this one, all these ones have the same layer, the one that is in red. Or for example, we can visualize that the layers that are more relevant here, the one that is, for example, orange and black, are not as prevalent on the east side. Or for example, that the total thickness of this well is bigger than the 54 is bigger than the one in 53, but the importance of the layer in orange is going to be more relevant in 53 than in 54. We can check which colors are associated with each layer by going here in edition layer data, here in static data we can modify the color that is associated with any layer. For example, 19 is in red by default, or we can change it to, for example, blue, and we save this option. It's not going to change immediately. Plenty of things like this in Sahara needs to be refreshed before being changed. So in this case, we are going to unselect this checkbox of the bubbles. So we are going to hide them and then show them again. And we can see now that the ones that were previously on red are now in blue. So now the color has changed. There are plenty more formats that allow us to see the information in plenty of other ways, but these two were just as an example. The simple format that is like the most basic, and this one per layer that is quite interesting when we had to compare different information, in this case petrophysical information, between layers. But I encourage you to experiment and see different combinations that might be useful for you. You can see production data or petrophysical data as well, or maybe data associated with flow elements. There are many different variables that we can see and many formats that we can use to show pretty interesting combinations of bubbles or bars as well with this function that allow us to see our reservoir in another light. So thank you for watching, and this will be all for this tutorial.